Everyone should have their 1C.11 part one notes. Yes, it folds, makes the little booklet and all that jam. I hope I did it. I hope I printed it correctly.
Yeah, it looks pretty good.
Yeah? Did I do okay? Okay. All right. So we are on part one of this. And again, it's gonna feel a little bit of repetitiveness from unit 1B, just because it's supposed to be building on from that and being in equivalent form. So basically our goal here will be to fine tune our techniques for analyzing graphs, okay? Mainly rational functions. And then to like just kind of reiterate our factoring techniques, making sure we're comfortable with analysis. So finding zeros, stating domains, stating the range. And then, yeah. So up first.
Give us an assignment on Sunday except for the circuit. Okay, that's what I thought.
Mhm.
What does it do?
Ready? That was not pre-cal. That was algebra 2. I don't think so. All right. So up first, we have x cubed minus 2x squared minus 15x. And we want to write an equivalent representation of this polynomial. What this is going to require is for us to remember our factoring techniques. Does that make sense? Yes, it's going to require us to remember factoring technique. The number one thing you should always start off with when you are factoring is finding the GCF. So we're going to start off asking ourselves, is there a GCF? And we're going to tell ourselves, yes, there is a GCF. And what is our GCF? X. So our GCF is X. So we're going to divide everything by X. So when I take out the X, I'm left with Y equals X times X squared minus 2X minus 15. Okay. After I've done that, now I can go through and remember our simple factors, right? Simple factoring is where you're talking to yourself and asking yourself, what multiplies to give me negative 15? What adds to give me negative 2? What kind of 5 and 3? A negative 5 and a positive 3. So y equals x times x minus 5 times x plus 3. So this would be my equivalent form of that polynomial. Yes? Okay, it's the factored form of it. The reason why we like the factored form is because from the factored form, I'm able to identify important information. And that important information is called my what? What do I know from the factored form? What does it help me find? My zeros. The factored form helps me find my zeros. So in factored, we can then find our zeros, right? All right, so now that I'm in factored form, what are the zeros of this polynomial? There we go. Our zeros are at x equals 0, x equals 5, and x equals negative 3. Okay, so this would be something on the non-calculator part. All right, so on the non-calculator, I would have to be able to identify the graph that represents this situation. That means putting into place all the things that I know about polynomial functions. Starting off with the fact that my leading coefficient is a positive 1, right? Because my leading coefficient is positive, that means that I know that we are up, right? We end up on the right and we start down on the left, right? So I know I have to do that. And then I now have my zeros, so I know I have to go through all of these points. So I have to go through negative 3, I have to go through 0, and I have to go through 5. And I have to make sure that I end on the positive side. So creating the sketch, I'm going to go, pew, pew, pew. So essentially, I would be looking for a graph that's modeled by this situation, right? I did. Did you not listen to my beginning speech? We've already learned. All right. So again, a lot of things said, like I said before we started, a lot of things are going to sound repetitive. That's because they build on each other. And these are things that we have to make sure we are comfortable doing all year long. Okay. All right. Up next. So here we have x squared minus 16 over x squared plus 3x minus 28. So example number one was a polynomial. Example number two is now a what? A what? A rational. Why is it a rational? It's a fraction. I have a polynomial in the numerator and I have a polynomial in the denominator, which makes it a rational function. Okay. So with this rational function, I would like for you to take a moment and factor using your factor skills and tell me, are there any wholes and or asymptotes? So you're going to factor. Huh? Yes. Good job. In order to identify your wholes and your asymptotes, you got to factor. All right. So factored form. What is my factored form? F of x equals what? What's my factored form? What's in the numerator? Perfect. Awesome. All right. So we're in fully factored form. In factored form, what do I know this happens here? There's a hole. Why is there a hole? There's a x minus 4 in the numerator and in the denominator. There we go. Does anyone know the value of the hole? Does anyone find it? You just plug 4 into what's left, right? So to find the hole, we have 4 plus 4 over 4 plus 7, which gives us 8 over 11. So our hole is at 4, comma, 8 over 11. All right. And therefore, where's our vertical asymptote? What's left? What's left in the denominator? 7. So where's my vertical asymptote? X equals negative 7. It was. No, I don't think it was like that. You should know why. It definitely was.
It was a lot more AP classes where it's been. I thought there was going to be on that paper.
Definitely.
It's definitely easy.
It was definitely the same. All right, here we go. Either way.
If you just put your email, that was yesterday concerning. You should send those students down to the senior staff that are on the list to Ms. White and the lawyer. Thank you.
Okay, so going really quickly here. Is it okay if I factor this fairly quickly? Are we comfortable with simple factoring? All right, so with simple factoring, all you're asking yourself is what multiplies to give you your constant, but adds to give you the coefficient of the middle term, correct? So in my factored form would be, there we go, x plus 4, x plus 3 over x plus 3, x minus 2. Agree? All right, because that is my factored form, I'm going to eliminate. So I'm left with what? X plus 4 over x minus 2. Okay, so my zeros, your zeros are based off of your numerator. After elimination, what's left in my numerator? 4, x plus 4. So therefore, where is my 0 at? Negative 4. So negative 4 comma 0. Agree? After elimination, all I'm left with is x plus 4. Okay. Then it says hole. Where's our hole at? Why is it at negative 3?
X is our liars and x plus 3.
There we go. It eliminated. So we're at x equals negative 3. If it asks me for the value, it says values. What does that mean I'm doing with that -3? I'm plugging it into what I had left, right? So -3 plus 4 is what? 1. And then -3 minus 2 is? So it's going to be at -1/5. Okay, vertical asymptote is based off of your denominator. What was left in my denominator? X minus 2. So if I take x minus 2, that means that I have a vertical asymptote at x equals 2. Horizontal asymptote. Ooh. Horizontal goes back to the original. Horizontal is based off of your degrees of your numerator and your denominator. If they are equal, it's just the what? 1/1, your leading coefficient. And what is our leading coefficient in both of them? So our horizontal asymptote is at y equals 1. So your horizontal asymptotes are based off of the degrees of your numerator and your denominator. If the degree of the numerator equals the degree of the denominator, you're only going to use your leading coefficients. If it's less than, then it's, there you go. All right. Your do now was to get you prepared for this, right? Can we write our domain? Yes. What is our domain? I started negative where? Negative infinity up until where? My whole. Because I have to stop at the whole. It causes me to stop. Uh-huh. I would get to -3 before I get to my asymptote. Remember, holes in asymptopes define, holes in the vertical asymptote define my domain, right? Then it's going to be -3 to 2. And then 2 to infinity. Okay. Your domain is based off of your holes and your VAs. Because I need to take my attendance. Yeah, you can. All right. All right. So again, you should be able to draw the sketch of it. So having your horizontal asymptote. There's one. And then my vertical asymptote. Yes. I'm in the middle of teaching. If he's just coming to return my calculator, sure. But I just can't help him. But he can sit in here all day. I don't care. He can work. I just can't help. He really can't do any work. I have a hole somewhere down here, right? No, what is it doing? Oh my gosh. My computer is glitching. Hold on. It just closed out of everything. No, it's not responding. What happened?